Okay, question 5. A block of mass 2 kilograms rests on a horizontal plane. A force P acts on the block at an angle of 45 degrees to the horizontal. The equilibrium is limiting, so it's on the verge of moving, and mu, the coefficient of friction, is 0.3. Find the magnitude of P if P acts in the downward direction. So what you've got going on here is your little sketch. You've got that is the block. You've got that's 2 kilograms. And for part A, anyway, I'll put this as part A. It says P acts in a downward direction, so it's still 45 degrees, so it's acting. You can either put it pushing like this, or you can put it pulling like this. I much prefer the pulling, so it doesn't matter which side you put it on, either here or here. Either way, you're going to need to componentalize this force. Okay, so that is force P. We're going to, it's rough. Okay, it's a rough horizontal plane, so you're going to need the normal reaction, R, and for that you're going to need its weight component, which is 2g, and therefore you know you're at F max because you're in limiting equilibrium just here. Okay, so we're at F max. Okay, right, so first thing you've got to do here is componentalize this force to a bit going this way and a bit going this way, and this bit here, well, it says 45 degrees to the horizontal. It doesn't matter if you label this 45 or this 45. I'm going to call this 45 just here. This is going to be the force P, and it is cos 45 is the component, and this one here is force P, and it is sin 45. Now, it says find the magnitude of P if it acts downwards. So I've got this. We've got to find the size of P is the game here. So I've got mu as my last thing is 0.3. Okay, there is one unknown, two unknowns, three unknowns. However, that is related to that. If I know this, I know that because I've already got mu r, so it's these two times together gives you that. So I'm going to resolve, and P is going to be in both of them, so I'm going to resolve vertically upwards. So resolve, and I'll say upwards is positive. Okay, and I'm using net forces is equal to ma. There's no acceleration going up or down, so it is equal to 0. So we've got R is the force acting upwards. The two forces acting downwards are negative because they're in the opposite direction, so that's 2g, the weight, and also this component here, which is minus P sin 45. And we know the sum of that is equal to 0. So therefore, R is quite clearly going to be 2g plus P sin 45. Okay, so it's all of that there. And then, therefore, because we're in limiting equilibrium, we know that F max will simply be equal to mu r, and mu is 0.3, so that's going to be 0.3 multiplied by 2g plus P sin 45. Okay, so that's all we can get to so far with that. So just here or underneath, resolve in a horizontal sense, we'll say that that is positive, and we're going to be using again net forces is equal to mass times acceleration. Limiting equilibrium means you're not moving, so it is equal to 0. So in that sense, you've got this is positive, P cos 45, and its only opposition is the F max. So minus F max, which we know is this, but I can't bother to write all that out, so I'm just going to write F max, and that is equal to 0. So P is simply equal to whatever our F max is divided by cos 45, and that's what P would have to be. So putting that in to F max on the calculator, let's work this out first of all. Okay, so 0.3 multiplied by brackets 2g, that's 19.6. well, we'll leave it like that and put 0. I'm going to do this sine 45 times by this here. Okay, so I've got that plus, and we know sine 45 is 1 over root 2 or root 2 over 2, so I'm going to use that as a in fact no, I'm not. I'm going to just AC that. I'm going to expand this out. First of all, I forgot about p's in there, so let's quickly undo that there. My bad. That there is being replaced with that because p's in there. Okay, so I've got p, I've got cos 45 minus f max, which is 0.3 multiplied by 2g, and it is plus p sin 45. Okay, and all of that is equal to 0. Okay, so expanding this out and gathering the p cos's, sorry, the p's, I've got p cos 45 minus 0.3 p sin 45. I do that times that gives you a negative, comes over, and that is equal to 2g times by 0.3. Factorize this by pulling a p out, and you end up with cos 45 minus 0.3 sin 45. Okay, and that is equal to 2g times by 0.3. And obviously, to finish that off, p is simply equal to whatever 2g is multiplied by 0.3, and it's all divided by your cos 45 minus your 0.3 sin 45. So that will give us to 3 sig fig, because we've used g, so 3 sig fig at most. Calculator back on, fraction button, bring it over here, so that's what I'm doing. Fraction button, 2 times 9.8 times 0.3. That is all over cos 45, close brackets, minus, open brackets, 0.3 multiplied by sin 45, close brackets, equals. And we get that, which is SD is 11.9 newtons. Okay, that's what it would be to be in limiting equilibrium. Okay, so second part of the question is if P acts in the upward direction. So if I just edit and clear annotation, and yep, so we've got part B now. So part B is virtually the same drawing again. You've got the block, which is 2 kilograms, but this time you've got P acting upwards in a 45 degree to the horizontal. Because we're in a limiting equilibrium, we're still going to need R. Now the only thing that F max will change is if R changes or mu changes. Mu doesn't change, but you can see R is going to be changed because it's going to be less, because it is aided by a component of that going upwards. So R is going to change. So we're going to need a new F max. So that's why we're going to go through this whole rigmarole again. That is F max going downwards, and that is going to be 2G. Componentalizing the force here, so a bit's going that way and a bit's going that way. So therefore 45 degrees to horizontal, I'll put that there. That is P cos 45, and the bit going up this time is P sin 45. So again, as we did before, resolving vertically and doing net forces is equal to no acceleration, so it's 0. I end up with the two positive ones are R, and it is plus P sin 45, and it is minus your 2G. And we know the sum of that is equal to 0. So R, quite clearly this time, is 2G minus P sin 45. And therefore that allows us to work out F max. F max, because mu hasn't changed, mu still is 0.3. F max is 0.3 multiplied by 2G minus P sin 45. Okay, That brings us on to resolving vertically upwards. Horizontally, I'll be right in a bit. Horizontally, to the right is positive. Net forces is equal to MA, which is 0. Okay, so my only positive force is my P cos 45, and it is taken away from F max, which is 0.3 times by 2G minus P sin 45. And we know the sum of that is equal to 0. So those are the only two forces horizontally, that and that. Right, expanding this out, you end up with P cos 45. I've got minus 0.3 times minus P, so it gives me positive 0.3 P sin 45. That times that is a minus thrown over, gives you 2 times that is 0.6 G. And finishing it off by factorising this, I end up with P, factorising it gives you cos 45 plus 0.3 sin 45, and that is equal to 0.6 G. And then finally, P is 0.6 G, and it is all divided by cos 45 plus 0.3 sin 45. And again, we can only do that to 3 sig fig because we've got G involved. So on the calculator, I see it, I've got fraction button 0.6 times 9.8, and that is over cos 45, and that is plus brackets 0.3 multiplied by sin 45, sin 45, close brackets equals, and this time I get 6.40 newtons to 3 SF. Okay, so two different answers. This is a lot smaller if P is acting upwards, and the reason being, if P is acting upwards, it's reducing R, it is reducing F max. Okay, so to keep it in equilibrium, you can only have, if this is smaller, you can only have a smaller amount going that way, so therefore this is reducing, and you can see that's a lot less than it was previously. All right, I hope that helps with that question.